Okay, this is the topic for review. So number one here says write a congruent statement for the two triangles to the right. So you can name the first triangle however you want. We can name it triangle CAR, triangle CRA, ACR, ARC, RAC, or RCA. So I'm just going to name it triangle CAR. Okay, and then we just have to match up the second triangle, the vertices of the second triangle with the ones on the first. So if I look here for C, okay, I have one hash mark and then two hash marks. So the C is between the one hash mark and the two hash marks. So if I look over here, between the one and the two is going to be the G. So C matches with G, so I'm going to start with G. A down here is between one hash mark and three hash marks. So between the one hash mark and the three hash marks is E. And then R is between the two hash marks and the three hash marks. So R is going to match up with O. So triangle GEO. So it's triangle CAR is congruent to triangle GEO, but there's 6 possible answers for this. Okay, the next one, there are 5 different shortcuts to show that triangles are congruent. So side, 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 angle, side, angle, side, angle, 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 side, and HL. Those are our 5 shortcuts. Our 5 theorems, our 5 shortcuts to show that two triangles have to be the same size and shape. All right, moving on though to number 3. So now we have to use those theorems to show that the two triangles are congruent. So in the first one, we have one pair of angles. We have a pair of sides. And then we have a second pair of angles. So that one's going to be angle, side, angle. That pair of sides is the included side. They're between the two pairs of angles. So angle, side, angle. Number 3, we have a shared side, so we can put a hash mark on the shared side. And then we have one pair of angle, a second pair of angles, and then our pair of sides. Okay, this time it's not between the two pairs of angles, so it's not angle, side, angle. It's going to be angle, angle, side. So this one is angle, angle, side. Okay, the third one here, C, we can add in our vertical angles. We know vertical angles are always congruent. We again have 2 pairs of angles, one pair of sides. This pair of sides is between or included. It's the included side. It's between the 2 pairs of angles. So that means we have angle, side, angle, because the side is between the sides here, are between the 2 pairs of corresponding angles. Okay, D, we can fill in our shared side. I'm going to put 3 hash marks there. And then you can use any of the theorems for this one. We could use side, side, side. We could use side, angle, side. We could use angle, angle, side. We could use angle, side, angle. Or we could use HL. We have right triangles. The hypotenuses are congruent. And we have at least one pair of sides. So any of them are going to work. I'm just going to put side, side, side. Okay, but you could put any of them, whichever one you want there. Okay, the last 2 down here. 3 pair of sides that are congruent. That's 1 pair, 2 pair, 3 pair. That's side, side, side. And then this one, we have a shared side we can add. Okay, so this would be angle, side, side. Angle, side, side is not one of our theorems, but if we get angle, side, side with a right angle, with a right triangle, we should look for HL. And so HL, we have right triangles, yes. We have hypotenuses that are congruent, yes. We have 1 pair of legs that are congruent, yes. So this would be HL, hypotenuse, leg. All right, and then over here, we have a shared side we can add. Okay, this gives us 2 pairs of sides. That's SS. Okay, but that's not going to be enough information. So NEI, not enough information. Okay, over here we have 1 pair of angles and 1 pair of sides. Again, we can't add anything else, so that's not going to be enough information. Not enough information. We need more than 1 pair of sides and 1 pair of angles. On I, we can add in our vertical angles here. Okay, add our vertical angles in, and then we have side, angle, side, right? The angle is between, it's included angle, meaning it's between the two sides that are congruent. So we have side, angle, side. And then over here, we have two pairs of angles. There's one pair of angles, two pair of angles, and then one pair of sides. Since the side is not between, it's not the included side between those two angles on either side, we're going to have angle side because it's not the included side. Okay, if the side was over here and here, then you'd have angle, side, angle. But it's not between, so it's not included side, so it's angle, side. All right, number 4, A and B. So it tells us here that triangle RSV is congruent to triangle TVS. So the triangles are congruent. That means their corresponding parts are congruent, right? CP, CTC, right? The corresponding parts of congruent triangles are congruent. So the first thing I can do is I can start by finding the third angle of this triangle. So 180 minus 90 minus 78 gives me 12 degrees. All right, and then everything from this triangle, I can match it up with the other triangle. So in this triangle, R matches with T, so T is also going to be 12. Okay, S is 90, it's going to match with V, so V will be 90 degrees. And then V is 78 in the first triangle, it matches with S in the second one, so this one is 78 degrees. So our first answer there is X equals 12 degrees. Well, actually, X just equals 12 because they have the degree symbol in there. So just X equals 12. Okay, the next one. Y here is part of RS. So RS is going to match up with TV. And since the triangles are congruent, we know their corresponding parts are congruent. So the corresponding sides are congruent. So we know 2y minus 1 is going to equal 24. And then from there, we can just solve. We'll add 1 to both sides. And we'll divide both sides by 2. And we get y equals 12.5. Okay, B. Let's start with X. So EF is going to match up with BC. So that means 4x plus, 4x plus 2.6. You probably need I can write it out. I'll write it out. 4x plus 2.6 equals 90.6. We can subtract 2.6 from both sides. And that's going to give us 4x equals 88. We divide by 4 on both sides, we get x equals 22. Okay, the other thing we need is y. So angle D here is going to match up with angle A. That means 2y minus 5 is going to equal 65. We can add 5 to both sides. And we get 2y equals 70. When we divide both sides by 2, we get y equals 35. Okay, so corresponding parts of congruent triangles are congruent. If you know the triangles are congruent, you know their corresponding sides are congruent, and their corresponding angles are congruent. All right, number 5, what additional information is needed to prove triangles congruent by the indicated postulate? So on the first one, we have one pair of angles here, and we have one pair of sides, which means we're missing a pair of angles. So what additional information do we need? We need a pair of angles. So we have two options. If we pick angle F and angle J, that's going to give us angle, side, angle. We don't want angle, side, angle. We want angle, angle, side. So we're going to have to pick angle G and angle L. So we're going to say angle G is congruent to angle L. It's not the best L. There we go. Okay, hypotenuse, leg. You need right triangles. We have right triangles. Okay, we have a shared side here, so our hypotenuses are congruent. And then the third criteria was one pair of legs. So it doesn't matter which pair. You can pick either pair, so we can say PS, segment PS, is congruent to segment RQ, right? Or we could do the other pair of legs. We could say PQ and RF. So you don't need both, you just need one. Just one pair of legs would give us enough information to use HL to show that the triangles are congruent. Okay, C, we can add in our vertical angles. So I'm going to put 2 arcs here and 2 arcs here. That gives us 2 pairs of angles, which means we need a pair of sides. So the sides need to be between the 2 angles, and they need to be the included side. So the one that's between angle W here and angle WXV is going to be WX. And then over here, it's going to be XZ. So WX, segment WX is congruent to segment ZX. That's number 5. All right, number 6. First thing I notice is I have an equilateral triangle. I know the angles of an equilateral triangle are all 60. So I can fill in 60. I could make it 0, 60, 60, 60. Okay, and then over here I have an isosceles triangle. I have 2 sides that are the same. Segment CD is congruent to segment ED. They each have 2 hash marks. So since I have isosceles, I'm looking at the 50 here, and that's my vertex angle, right? My bases are across from the sides that are congruent, so that means this is the vertex angle. So we're going to do 180 minus 50. And then we're going to split it in half. We're going to divide by 2 and get 65, right? So these 2 angles, they have to add up to 130, and they have to be equal to each other. So that's why we divide by 2, and we get 65 and 65. From there, we just have linear pairs, vertical angles. So these 2 are a linear pair. So 180 minus 65 is going to give me 115. Okay, here these 3 angles should add up to 180, right? All 3 of those. So I can do 180 minus 60 minus 65, which gives me 55. So those 3 angles have to add up to 180 because they form a straight line, a straight angle. And then over here we have vertical are congruent, and then we can do 180 minus 60 gives me 120. Once we fill all the diagram in, we can start answering our questions over here. So BCA is 60 degrees. DCE, that's this angle here, DCE is 65. DEF is 115. BCD is 55 degrees. Right, all should have the degree symbol. Okay, BAG is 120 degrees, and then GAH down here is 60. All right, that's number 6. All right, let's move on to number 7. Okay, number 7, what is the perimeter of triangle ABC? So if this side CD is 10, BD also has 1 hash mark, right? 1 hash mark, 1 hash mark. That means this is 10. Okay, hash mark here, that leaves us to be 10 here as well. So the piece we're missing is AB. So we're going to have to look at more information, and they're giving us 60 degrees. So since this has 2 sides congruent, it's at least isosceles. So across and across have to be equal, which means this angle down here in our isosceles triangle, this other base angle is 60. But we notice if we have 60 and 60, the third angle is going to also have to be 60. So 180 minus 60 is going to give me 60. So if all 3 angles are 60, that means this is equilateral, which means this side is also going to be 10 units as well. Because it has to be equilateral because all of the sides I'm sorry, all of the angles are 60, so that means all the sides have to be equal. So perimeter is the length around. So we're looking at triangle ABC. Is that we're looking for the perimeter of triangle ABC? So we're just looking at this blue length here that I'm putting in. So the numbers we need to add are 10, 10, 18, and 10. We don't add this 10 in the middle because that's not part of the perimeter of triangle ABC. That's segment BD. That's not part of the perimeter of triangle ABC. So we're going to do 10 plus 10 plus 18 plus 10 gives us a grand total of 48 units. So that's perimeter. B says, what's the measure of angle C? That's this one over here. So we know these were 60, 60, 60. We have a linear pair here. So 180 minus 60 gives me 120. Right. And then this is an isosceles triangle, this triangle at the top here. So again, base angles are across from the sides that are congruent. That's our isosceles triangle theorem. So that means my base angles are over here at angle DBC and angle C. So that means this is the vertex angle. So we need to subtract from 180 and then divide by 2. So 180 minus 120 is 60, and then we're going to divide by 2. Oops. And that's going to give me 30. So each of these angles here are 30 degrees. 30 degrees. So what's the measure of angle C? It's 30 degrees. All right, number 8. Next. So I notice I have two isosceles triangles. So if this is 5, this length over here is 5. And then this one's 5. So this one, PS, segment PS, is also 5 because they're isosceles and they all have the 1 hash marks. All right, if I'm looking for a perimeter, I need to add up we're looking for the perimeter of triangle PQR. So I'm adding up 6, 9, 5, and 5. Right, I'm not adding this 5 because segment QS is not part of the perimeter of triangle PQR. It goes through the middle of triangle PQR, but it's not part of the perimeter. The perimeter is the length around the outside of the triangle. So 6 plus 9 is 15, plus 5 plus 5, that's 25 units. All right, and the measure of angle P, so we got to do angles now. Test, Mike. That works fine. Oh, it's still recording. That's fine. Okay. So it's isosceles here. So base angles are both 40. So let me change the color here, which is what I was going to do. So 40 and 40 down here. And to find the third angle of our triangle, we got to do 180 minus 40 minus 40. It's going to give me 100. Yeah, it should still be recording, I think. Hopefully. So this is 100. Okay, and then these two angles here form a linear pair, right? It forms that straight line, straight angle. So we can do 180 minus 100, which gives me 80. And then this isosceles triangle here, the base angles, again, are across from the sides that are congruent. So that means we have a vertex angle. So we need to subtract from 180 and then divide by 2. So 180 minus 80 is 100. And we divide by 2, that gives us 50. So these two angles here are 50 degrees and 50 degrees. All right, so the measure of angle P here is 50 degrees. All right, now we just have the proofs. So let's go do the proofs. Okay, so this one, again, I don't think it got messed up for whatever reason. I don't know why. But we're not proving this. Right? We're trying to prove that triangle KAT is congruent to triangle YHT. All right, so we're going to put statements on the left. Get some bigger font here. And then put reasons on the right. Draw a line down the middle. There we go. All right, number one is always your given. So we're going to write in our given. Okay, and over here we're going to say KA is parallel to HY. And T is the midpoint of KY, segment KY. All right, so first thing we want to look for is shared sides. We don't have any shared sides. Second thing we want to look for are vertical angles, and we do have vertical angles right there. Okay, so my step 2 is going to be the vertical angle theorem. My vertical angles, remember T needs to be in the middle when I name these angles because it's the vertex of the angle. So I'm going to do angle KTA. Is congruent to angle YTH. And the reason that's true, reason we know that statement's true is because the vertical angle theorem. Okay, step 3 on our list is midpoints, and we do again have a midpoint. So KY is the midpoint. I'm sorry, T is the midpoint of KY. Okay, so if I look at this, here's KY. And T is right in the middle. Okay, T's right in the middle. So if KY was 10, just hypothetically, then KT would be 5 and TY would be 5, right? Because we're splitting the 10 in half, 5 and 5. That means we know that segment KT is going to be congruent to segment TY because T is in the middle of K and Y. So segment KT is congruent to segment YT. And that is the definition of a midpoint. That's the definition. Midpoint. Okay, next on our list is parallel lines, which we have. We have parallel lines right here. Right here. So if you have parallel lines, you're looking for alternate interior angles. So let me highlight our parallel lines. KA is parallel with HY. Okay, and then it doesn't matter. You have 2 different transversals. I'm just going to use this one. Okay, you could use either one. Different answers here. And my alternate interior angles are going to be angle A and angle H. So I can say angle A is congruent to angle H. And the reason is the alternate interior angle theorem. Those are alternate interior angles. You could also do K and Y. Okay, that would be fine. Okay, and then now we have enough information. We can use angle, side here. So angle, side. And that's going to tell us that our triangles are congruent, which is what we're trying to prove. Triangle KAT is congruent to triangle YHT. I could draw a good T. There, and we're done. Okay, if you chose to do angle K and angle Y were congruent by the alternate interior angle theorem, then you would have angle, side, angle. So if you pick K and Y instead of A and H, then you would have angle, side. All right, that's number 9. We got one more, number 10 on here. Okay, so again, another proof. So we want to start with statements. And then reasons. And draw my chart. Change the color. Okay, and we're going to start with a given. So we're given two things. We're given that AB is parallel to ED. Segment AB is parallel to ED. And that is given. All right, we're also given that AB is congruent to AB. So I'm going to put a hash mark here and a hash mark here. So segment AB is congruent to segment ED. All right, so let's go down our list. Do we have a shared side? No. Do we have vertical angles? Yes, we do have vertical angles. So I'm going to fill in my vertical angles. Okay, and that can be my step 2. Angle, again, C is in the middle. C is the vertex. So when we name it, we got to have the C in the middle. So I'm going to do ACB. Is congruent to angle ECD or DCE. As long as C is in the middle, we don't care. Name it either way. It's the same angle regardless of how you know, as long as you name it correctly. Okay, and that's the vertical angle theorem, VAT. Vertical angles are congruent. Okay, as we continue down the list here, midpoint, we don't have any midpoint, right? C looks like a midpoint, but there's nothing that tells us with 100% certainty that it is. 4 is parallel lines, and we do have parallel lines right here. So if we have parallel lines, again, we're looking for alternate interior angles. Let's highlight our parallel lines and extend them. Okay, and again, on this one, you can pick either pair. I'm going to pick AE as my transversal. All right, so there's my transversal. So my alternate I think it should be fine. My alternate interior angles, right, should be angle A and angle E. So for step 3, we can say angle A is congruent to angle E. And that's the alternate interior angle theorem. When you have parallel lines, you're looking for alternate interior angles. Right, and then now we can say our triangles are congruent by angle, angle, side. So by angle, angle, side, right, we can say here that triangle ABC is congruent to triangle ECD. For alternate interior, again, if you would have picked BD, segment BD as your transversal, then you could have said that angle B is congruent to angle D. And then that still would have been angle, angle, side. Okay, or you could have used alternate interior angle theorem twice and then used the angle, side, angle. That would have been fine. So again, many different ways to do some of these proofs.